At first glance, the universe looks chaotic. Stars explode, galaxies collide, particles behave unpredictably. Life itself appears messy, fragile, and uncertain. From the smallest quantum fluctuations to the largest cosmic structures, nothing seems perfectly ordered. And yet, the deeper scientists look, the more a surprising pattern emerges. Beneath the apparent chaos of the universe, there is a quiet, persistent order, not imposed from above, chapter not designed with intention, but emerging naturally, again and again. For centuries, humans searched for certainty. We wanted fixed laws, predictable systems, a universe that behaved like clockwork, and in many ways, physics delivered that vision. Planetary orbits follow precise equations. Gravity behaves consistently. Light travels at a constant speed. But as science pushed deeper, that sense of certainty began to soften. At the smallest scales, particles do not follow exact paths. They exist as probabilities, as distributions, as likelihoods, rather than guarantees. The universe, it turns out, is not perfectly predictable. But unpredictability is not the same as disorder. One of the most important insights of modern science is that order does not require control. It can arise spontaneously from simple rules interacting over time. This idea is known as emergence, and once you see it, you begin to notice it everywhere. Consider something simple, a snowflake. Each snowflake begins as a tiny particle of water. There is no blueprint, no instruction set dictating its final shape. And yet from random molecular motion, intricate symmetry appears, six-fold patterns, repeating structures, order formed from chance. The snowflake is not designed. It is allowed. The same principle scales upward. In physics, systems tend toward disorder. Entropy increases. Energy spreads out. Structure decays, and yet local pockets of order continue to emerge. Stars form from diffuse clouds of gas. Planets condense from cosmic dust. Galaxies organize into vast repeating structures across billions of light years. These structures are not imposed. They arise because the laws of physics allow matter and energy to organize under the right conditions. Chaos does not prevent order. It makes order possible. This pattern does not stop at physics. It extends into life itself. Biology is noisy, messy, full of randomness. Mutations occur by chance. Environments shift unpredictably. Cells operate under constant uncertainty. And yet, from this apparent randomness, complex life emerges. Cells organize into tissues. Tissues form organs. Organisms coordinate trillions of interactions without central control. Life does not eliminate chaos. It learns to work with it. The human brain reflects this same principle. Neural activity is not perfectly synchronized. Signals are noisy. Connections vary from moment to moment. And yet, from this dynamic instability, thought emerges. Memory forms. Perception stabilizes. Consciousness arises. The brain does not operate like a rigid machine. It behaves like a system balanced delicately between order and disorder. Too much order, and it becomes rigid. Too much randomness, and it becomes incoherent. Intelligence lives in between. This balance appears again and again across the universe, in weather systems, in ecosystems, in markets, in galaxies. Systems that are too ordered cannot adapt. Systems that are too chaotic cannot sustain structure. But systems poised between the two can evolve, learn, and persist. This region is sometimes called the edge of chaos, and it may be one of the universe's most important organizing principles. Even mathematics reveals this hidden structure. Simple equations can generate extraordinarily complex behavior. A few lines of code can produce fractals with infinite detail. Tiny changes in initial conditions can lead to dramatically different outcomes. Not because the system is broken, but because it is sensitive. Chaos, in this sense, is not randomness. It is structured unpredictability. This perspective changes how we think about uncertainty. Uncertainty is not a flaw in the universe. It is a feature. It allows exploration, variation, creativity. Without uncertainty, nothing genuinely new could arise. No stars, no life, no intelligence. The universe would be static, perfectly ordered, and lifeless. Even at the quantum level, this pattern holds. Particles do not have fixed positions until they are measured. Outcomes are probabilistic, and yet when vast numbers of particles interact, predictable patterns emerge. The macroscopic world feels stable because randomness averages out. Order emerges statistically, not absolutely. This reframes how we view the cosmos. The universe is not fragile. It is dynamic, robust because of its variability, resilient because of its flexibility. Order is not imposed despite chaos. It arises because of it. There is something deeply reassuring about this idea. It suggests that uncertainty is not something to eliminate. It is something to understand. Complexity is not a problem to solve. It is a condition to navigate. The universe does not promise certainty. It offers coherence. When we step back far enough, a quiet pattern becomes visible. From quantum fluctuations to galaxies, from chemistry to life, from neurons to minds. The same principle repeats. Simple rules, local interactions, no central control, and yet remarkable structure. This may be one of the most profound insights science has ever revealed, that the universe does not need a detailed plan to create complexity. It needs only rules, time, and freedom to vary. In a world that often feels unpredictable, this hidden order offers a different kind of clarity, not certainty about outcomes, but confidence in process. That structure can emerge even when control is incomplete. That meaning can arise without design. That chaos and order are not opposites. They are partners. The universe is not perfectly ordered, and it is not truly chaotic. It is something richer. A system that continuously balances between stability and change, between predictability and surprise, between structure and freedom. And perhaps that is why life fits so naturally within it, because life too exists in that same balance. Not fully controlled, not fully random, organized enough to persist, flexible enough to evolve. When we look at the universe this way, chaos becomes less frightening. It becomes generative, a source of possibility, a reminder that complexity does not require perfection, only the right conditions to unfold. Beneath the apparent chaos of the universe is not disorder. It is a deeper order, one that does not announce itself loudly, one that reveals itself slowly to those willing to look. And once you see it, the universe no longer feels random. It feels alive with structure,